Welcome to lecture 13 on stochastic processes. In this lecture, today I am going to discuss three problems and their solutions. So, the problem number one is as follows. One day, on any given day, Mr. Bachchan is either cheerful, represented by capital C, so that means capital S, or glum, in short, capital G. So that means on any given day, Mr. Bachchan has three states of mind: cheerful, so or glum. If he is cheerful today, then he will be cheerful, so or glum tomorrow with respective probabilities zero point 0.5, zero point 0.4, zero point 0.1. If he is feeling so today, then he will be cheerful, so or glum tomorrow with probabilities zero point 0.3, zero point 0.4 and zero point 0.3. If he is glum today, then he will be cheerful, so or glum tomorrow with probabilities zero point 0.2, zero point 0.3 and zero point 0.5. Now, obtain the transition probability matrix. First question. And second is, using this transition probability matrix, find the probabilities that if he is cheerful today, then he will be cheerful next 2 days. If he is so today, then he will be cheerful after 2 days. If he is glum today, then he will be cheerful day after tomorrow. So we will see the solution. So now first thing is what is the transition probability matrix. So first we write down that what is my stochastic process. So let xn be the state of mind of Mr. Bachchan at the nth day. Okay. Then xn n ranges from 0, 1, 2 and so on. This represents the stochastic process. The stochastic process related to related to the given problem. So here n is equals to 0, that means x0. x0 represents the state of mind at today. So that means n is equals to 0 represents today. Okay. N is equals to 1 represent tomorrow. N is equals to 2 represent day after tomorrow and so on. So now first question is whether this Markov process, this is a Markov chain or not. So you can see that what is the state space. So state space of this process, state space, if I represent it by S, I should not represent it by S, I am representing it by S star. So it contains C, S and G. C stands for cheerful, S stands for so and G stands for glum. So only these three possibilities are there for these random variables. And you can see that this is a discrete set, and n is equals to 0, 1, 2, that means time set is also discrete. So it is a discrete time process. Now whether it is a Markov chain or not, so you can see easily that future is only depending upon current. It is not depending upon past, because it is given that if he is feeling so today, then he will be CSG tomorrow with these probabilities. Everywhere it is written just with the current situation. What he is feeling today, future only depends upon that. So this is a Markov chain. So we can write down that it is a Markov chain. It is a discrete time Markov chain. Now we have to first find out the transition probability matrix. So what is that here? So P is, there are C, S and G. So if I put C, S and G here, so what are the possibilities? So if he is cheerful today, he will be cheerful, so glum tomorrow with respective probabilities 0.5, 0.4 and zero point 0.1. So probability will be 0.5 here, C to C, C to S it is 0.4 and C to G it is 0.1. So C is the today's status and these CSG column wise they are the tomorrow's status. So this is the one step transition probability from C to C, C to S, C to G. And then if he is feeling so today, then he will be C, S or G tomorrow with probabilities 0.3, 0.4 and zero point 0.3. If he is glum today, then he will be C, S or G tomorrow with probabilities 0.2, 0.3 and zero point 0.5. So this is our transition probability matrix. So the transition probability matrix is given by this. Now what are the questions? So first part is A part. What it says, it asks that, so if I read out A part says that if he is cheerful today, so that means X0 is C. If he is cheerful today, then what will be when then he will be cheerful next 2 days. See, cheerful next 2 days means on the next day he is cheerful and on the next day he is cheerful. So he is cheerful today and he will be cheerful next 2 days. That means he will be cheerful continuously. So required probability. So we want to find the probabilities. So what is the required probability in part A? So required probability is nothing but we have to find that on the second day he is cheerful, on the first day he is cheerful, given that today he is cheerful. This we have to find out. Okay. So how to find out it? It is very simple. You have to conditioning x2 is equals to c, given that x1 is equals to c and x0 is equals to c, multiply by x1 is equals to c, given that x0 is equals to c. So this is straightforward, nothing very important. If x0 is equals to c is given, you find the probability on the next day, that is this. So today you are cheerful, what is the probability that on the next day you are cheerful? Now today you are cheerful, next day you are cheerful, then what is the probability that again in the next day you are cheerful? So now since it is a Markov chain, your future only depends upon the current, not on the past. So x2 is equals to c only depends upon x1 is equals to c, not on this. So this will be x1 is equals to c, given that this. So since it is a Markov chain. Remember that since it is a Markov chain, we can write it down this equal to this. Now this is very straightforward. You want to find C to C. See, this is also time homogeneous Markov chain. So there is no the only steps 1 to 2. That means you are taking just one step. So this is the probability going from C to C. So this is nothing but P C to C in one steps. This is nothing but P C to C in one steps. So you can see that C to C, the probabilities are 0.5 into zero point 0.5, which is nothing but 0.25. So this is the answer of first part. Now we focus upon the part B. So what part B says? Part B asks that if he is so-so today, then he will be cheerful after 2 days. So-so today and cheerful after 2 days. So we are interested in he is cheerful, sorry, so-so today. Okay, he is so-so today and after 2 days. So after 2 days means tomorrow and day after tomorrow we have to leave them. So on the x3 will be C. That is the question. Because if you represent 0, this is today. Then after 2 days means these are 2 days. Then after 2 days, this is the third day. So this is after 2 days. So x3 is equals to C and x0 is equals to S. So we just read it once again. Part B, if he is so-so today, then he will be cheerful after 2 days. So today and cheerful after 2 days. Now you have to find out this. So how to find it out? So one method is this is if you see, you just find out probabilities p cube, because this is one step, then two step, then three step. So if you find out p cube, and then from that p cube you can find out this probability. Otherwise you can find out this probability by making tree diagram. So again by this thing, that means from S to you can go to C, S or G and so on. So I have calculated these probabilities, so I am writing here separately. So this is, if you can easily calculate p square, that means p multiplied by p. So it will come out to be 0.39, 0.33, 0.29, 0.39, 0.37, 0.35, 0.22, 0.30, 0.36. And if you find out p cube, it will be 0.356, 0.378, 0.266, 0.336, 0.370, 0.294, 0.322, 0.364, 0.314. So if I focus upon here in this problem, what it says? It says that you have to move from S to C in how many steps? In 3 steps. Because 0 to 3, there are 3 steps. So this will be what? This will be the C, where is this is C, this is S, this is G. This is C, this is S, this is G. So you are moving from S to C. From S to C, that means the answer will be 0.3 3, 6. So this is the answer. So this answer comes from PQ. That means the second row and first column. You are getting this. So this is the one method. That means if you find out the PQ, and then you can find it out. Otherwise, you have to write down all the possible paths, and then you can use the possibility, or you can multiply all those probabilities. So I will show you how to do that. So for example, this is the today situation, this is the next day, this is the next day, and this is the next day. So if you are saying that today the situation is S, that means you are in so-so mode. Then from S, you can move towards S or C or G. Then from this C, you can move from C to C, C to S, or C to G. Similarly, from this S, you can move from C to C, S, or G. Similarly, from G, you can go to C, S, or G. On the third day, you have to move at C from all the places. From all the places, you have to come to C, because that is our requirement. So one method is you just write down these probabilities from S to C, then C to C, then C to C. From S to S, and then S to C, and is all these probabilities. So one method is that you can find out all these probabilities and add them, but that may be complicated. So you just find out this P cube. So that is here I am writing. One can also find out, one can also find out, uh, one can also find the same answer using the above tree diagram and respective one step and respective one step one step transition probabilities, that you know. Transition probabilities, what does it mean? You know that what is the probability going from S to C, then C to C, then C to C. So you multiply all those three probabilities. Then S to C, C to S, then S to C. All those probabilities. So you multiply and then add them, those things, you will get the answer. So that was second part. And the third part, what it says. So what is third part? Third part is, it asks that if he is glum today, then he will be cheerful day after tomorrow. Okay. So what is the probability of that? Glum today and cheerful day after tomorrow. So this asks actually, what it says that, it says that it glum today, is glum today and cheerful day after tomorrow. So day after tomorrow means on the second day. So now we need this. So again, this is nothing but this is the probability going from G to C in two steps. So we have already seen that what is P square. So we have seen that P square is here. So this is your C, this is your S, this is your G, this is C, this is S, this is G. So what we need G to C. G to C in two steps. That means probability 0.29. The answer is 0.29. So this is nothing but 0.29. So this is from P square. So again you can make the tree diagram and find out this how 0, 1, 2. So if you make the tree diagram, your current position is G and your last position is C. So in between you may be C, you may be at S and G. So G to C one movement, C to C another movement, then G to S, then S to C, G to G and G to C. So you can see what are the probabilities. So G to C, the probability is 0.2 and this is 0.5. From G to S, this is 0.3. From S to C, this is 0.3. You can see in the one-step transition probability matrix that G to C is nothing but zero point 0.2 and from C to C, it is 0.5 and so on. So now this is 0.5 and 0.2, zero point 0.5 and zero point 0.2. So what is how you find the probability? So required probability by tree diagram, that will be 0.2 multiplied by 0.5 plus 0.3 multiplied by 0.3, that means this 0.2 zero point 0.5 then 0.3 zero point 0.3 then 0.5 multiplied by 0.2. So 0.2 multiplied by zero point 0.5, then you add 0.3 because this is mutually exclusive paths, then 0.5 and 0.2. So what is this? This is 0.10, this is 0.09, this is 0.10. So what we are getting? We are getting 0.112 and 9, which is the same answer here. So this I was talking in this case also. In part B, you just write down all these one step transition probabilities and then find out the probabilities of each path and then add them. Then you will get 0.336. So this was the problem number first. We have seen that how to solve this problem. Now we move towards problem number 2, which was asked in GATE 2019 in statistics paper. It was question number 11 in that paper, and what it says that consider a discrete time Markov chain on state space 1, 2, 3. That means there are three states 1 and 1, namely 1, 2, 3, with one step transition probability matrix this. The question asks that which of the following statements is true? States 1, 3 are recurrent and state 2 is transient, state 3 is recurrent, states 1, 2 are transient, states 1, 2, 3 are recurrent, states 1, 2 are recurrent and state 3 is transient. So actually it is asking about the nature of the states, whether they are transient or they are recurrent. So that is the main question. So first we see what is the transition graph. So state 1, state 2 and state 3. So there are three states. 1 to 1, there is a possibility going from 1 to 1 with the probability 0.7. Then 1 to 2, there is a probability 0.3. So 1 to 1 is possible, 1 to 2 is possible, 1 to 3 is not possible. Then 2 to 1 is not possible, 2 to 2 is possible. So 2 to 2, it is possible with probability 0.6. Then 2 to 3, it is possible to move with the probability 0.4. Then from 3 to 3 only possibility is from 3 to 3. So this is one. Now first we see the nature of this Markov chain. So whether all states are communicating with each other, first we see. So 1 to 1 is possible, 1 to 2 is possible, but 1 to 3 is not possible. So 3 is not accessible from 1. Similarly, 2 to 2 is possible, 2 to 3 is possible, 2 to 1 is not possible. And 3 to 3 only possibility is 3 to 3. So that means they are no state is communicating with any other state, because in communication means they must be accessible from each other. So no state is communicating with any other state. So that means it is not a irreducible chain, it is a reducible chain. You can see there is a separate classes 1, 2 and 3. So 1 is a separate class, 2 is a separate class, 3 is a separate class. So that means 1, 2 and 3 may have different states. That means they may be recurrent or they may be transient. So we have to find whether they are recurrent or transient. So if I focus upon state 1, then you can see that from 1 to 1 there is a probability 0.7, but 1 to 2 there is a probability 0.3. And whenever you leave 1 and move to towards 2, you will never return back. So, in a simple way, it is seen that whenever the process leaves state 1, it will never return to state 1, and there is a positive probability of leaving state 1. So, state 1 should be transient, okay, in that sense. If I focus upon state 2, again the same argument will work, because from state 2 state 3 there is a positive probability of moving from state 2 to 3, and whenever you leave state 2 you will never return back. So state 2 should be transient, and state 3, whenever you leave it you will always return back. So this state should be recurrent. So these are the answers by just seeing and arguing something, but we will find the answer using the proper definitions and proper mathematics. So what we are observing that 1 and 2 should be transient and 3 should be recurrent. So answer should be option number B. State 3 is recurrent and states 1 and 2 are transient. So answer should be state B, option number B. Now we will find out it mathematically. That means we will write down everything and we will use the definition. So if you remember the definition, then there was F11, F11 N. So we will find F111. That means returning to 1 in 1 steps first time. So this probability is nothing but 0.7. If you focus upon 1, 1 in 2 steps first time, so see, when you leave it, you will now never return back. And when you leave in this path, you will return back within 1 step. So this will be 0. Similarly, F113 will be 0. Remember that all of them are returning from 1 to 1 in 3 steps first time. So first time it is not possible. So you can easily see that summation F11N, n ranges from 1 to infinite, this will be nothing but 0.7, which is less than 1. So this implies that state 1 is transient by definition, because what was the definition? Definition was if this sum comes out to be 1, then state is recurrent. Other, if it is less than 1, state 1 is transient. So one method is to using F11. Similarly, what is F221? So 221 is 0.6, and what is F22N? So that is 0 for every n which is greater than or equal to 2. Why? Because when you leave 2, you will never return back here if you are going towards 3. If you are leaving 2 and returning back with this path, so it will be first time in 1 step. It is not possible first time in second step or third step and so on. So this also implies that summation F22 n ranges from 1 to infinite is nothing but zero point 0.6, which is again less than 1. So this implies that state 2 is also transient. Now we will focus upon state 3. So what is F33N? So you can easily see from 3 to 3 there is only single path. So 3 to 3 in one step. So 3 to 3 in one step, this is 1. And from 3 to 3 in any other step, first time that will be 0, because whenever you leave it, you will return back first time in one step. You cannot return back first time in more than one steps. So all these probabilities will be 0. So this again implies that summation f33 n ranges from 1 to infinite, this comes out to be 1. So this implies that state 3 is recurrent. So this is one method. One method was just by observation. So see, one is just by observation. You observe that whenever you leave 1 and go to 2 with probability 0.3, you will never return back. So this is transient. If you leave 2 and go to 3, you will never return back. This is transient. If you leave 3, you will always return back. So this is recurrent. So that was the observation. And this method, if I call it method 1, method 1, so this is using small fii. Now there is another method, if you remember, I have discussed in one of my lectures, that we can find out transient, and I have proved a theorem that if I is recurrent, then sum of pii n, that series diverges. So if we focus upon that also, then what will be the answer? So you can see that p 1 in n steps. If you want to return back, that is 0.7 to the power n. Why? Because from 1 to 1, only possibility is self loop. Only possibility is self loop. So in one steps it is 0.7, in two steps it is 0.7 square, it is in three steps it is 0.7 to the power 3, and so on. So this probability is P11n is 0.7. So what it will imply? It will imply that summation P11n n ranges from 0 to infinite. This is the second method. So if you remember that P110 is always 1. Okay. So this will be nothing but 1 plus 0.7 plus 0.7 square plus dot dot dot. So that is 1 plus 0.7, then 0.7 square. So, and this is nothing but a sum of infinite GP. So this is A upon 1 minus R. So that means 1 divided by 0.3, which is a finite number. So if you remember that theorem says that if this sum is convergent, then a state must be transient. So this implies that state 1 is transient. So similarly, you can see for other states. So if you focus upon P220, that will be 1 P2 to n steps. So what is the probability? P22. So if you focus upon, that is nothing but 0.6 to the power n. So this implies that summation P2 to n ranges from 0 to infinite, it will be 1 plus 0.6, 0.6 square, and so on. So this will be 1 divided by 1 minus zero point 0.6, which is 1 divided by zero point 0.4, which is a finite number. So this again implies that state 2 is transient. Now what about state 3? So what is state 3? So P330, that will be 1, no problem. What is P33n for others? So remember that that is also 1, because if you see the transition graph, 3 to 3 only the possibility is that 3 to 3. So all the probabilities are 1 actually. So if all of them are 1, then what is the sum? N from 0 to infinite, P33N. So what is this sum? This sum is 1 plus 1 plus dot dot dot. You know that this is a divergent series. So if this is a divergent series, then state 3 is recurrent. So remember that this condition, if the series diverges, state 3 is recurrent. If you remember that what this summation implies, this summation is the expected number of visits to the state 3 if process starts in state 3. So if the expected number of visits are infinite, that means state 3 is recurrent. If the expected number of visits are finite, then state is transient. So that was the idea. So we can see that this problem can be solved by just by observation or just by using a small f function, a small f probability, that means probability of first time transition, or probability is p. So this was the problem from GATE 2019. Now we will focus upon another problem from the same exam, the question number 22, and it says that if let xn be a discrete time Markov chain on state space 1, 2, 3 with one step transition probability matrix given by this, and initial distribution. With this initial distribution means when process starts, it 0.5 is the probability that it starts in state 1, and zero point 0.2 is the probability that it starts in state 2, and zero point 0.3 is the probability it starts in state 3. Now question is, evaluate this probability. So what is the answer of this question? So we will see the solution. We have to find probability x1 is equals to 2, x2 is equals to 3, and x3 is equals to 1. So what happens here, if you focus upon, so there is a time is 1, 2 and 3. So this is time, and state is 2, 3, 1. This is state. So time is 1, 2, 3, state is 2, 3, 1. So we do not know what happened at time 0. That we do not know. So if we know that, then we can find out all these probabilities using Markov property that future will only depend upon current. So first thing is, we will condition upon initial thing, because we do not know what was the initial starting point. That means we do not know what was this. So we consider that this x naught was actually I. So if it is, you are writing this way, then you have to multiply with this with theorem of total probability. So it says that I can be 1, 2, 3, anything. So that means if process starts from I, then what happens? So this process can start from I is equals to 1, or I is equals to 2, or I is equals to 3. So in all these cases, we will find the probabilities and add them. Now I will just write down these probabilities using Markov property, because now you know this original situation. So I am writing here P is equals to x0, and I am assuming that it starts from 1. Okay. If it starts from 1, then on the next step, that means here, see, if it starts from, it can start from 1, it can start from 2, it can start from 3. So if it is starting from 1, the next step is 2, then next step is 3, and then next step is 1. If it is starting from 2, the next step is 2, 3, 1. If it starts from 3, the next step is 2, 3, 1. So in any case, next steps are fixed. Only the first step you do not know. So using Markov property, we know that if it starts from 1, then going from 1 to 2, that is nothing but one step transition probability 1 2. Okay, then going from 2 to 3, that is p to 3. Why I am writing this? Because I am using Markov property that this 2 to 3 movement will not depend upon whether you have come from 1 or 2 or 3. Because if you are going to 3, it only depends upon the current situation, that means you are in 2. Whether you have reached 2 from 1 or 2 or 3, that does not matter for us, because it is a Markov chain. So it will be going from 1 to 2, then from 2 to 3, and then from 3 to 1 at last. Plus, now you start from state 2. Then if you are starting from state 2, then you can move from 2 to 2, and then from this 2 to 3, and then from this 3 to 1. Again I am using Markov property that from 2 to 3 it will not depend upon the past. So I am just writing this. Plus the third condition is you are starting from 3. So if you are starting from 3, then you can move from 3 to 2, then from 2 to 3 again using Markov property, then from 3 to 1 again using Markov property. So you can see that this P23 P31, that is common. So what we are having, Px0 is equals to 1 multiplied by P12 plus probability x0 is equals to 2 multiplied by P22 plus probability x0 is equals to 3 multiplied by P32. All these things 2331, 2331 and 2331, they are common. Now we have to just put the values of these probabilities. So what is P23? 2 to 3, that means it is 0.3. You are moving from 2 to 3. 3 to 1, so 3 to 1 it is 0.2. And here x0 is equals to 1, it is given 0.5. 1 to 2, 1 to 2, that is 0.3. Then x0 is equals to 2, this is 0.2. 2 to 2, this is 2 to 2, that means second column, second row. So that is again 0.2. X0 is equals to 3. So x0 is equals to 3, it is given 0.3. Then 3 to 2, that means third row, second column, 0.4. So what we are getting? 0.3, 0.2, 0.5 multiplied by 0.3, 0.2 multiplied by 0.2, 0.3 multiplied by 0.4. So if you calculate all these things, I will not calculate here, you will get 0.0186. So this is the answer of this question. So today we have gone through 3 problems, 2 from GATE 2019 exam, and you can see that these problems are not very difficult. These problems are very easy if you know the basic concepts. So I hope this will be helpful for you to solve more problems on the same type. So I suggest you to search similar problems and solve them. So thank you for thank you for this for your support and your interest.